Good morning and Sairam. So we are doing our last chapter of chemistry, chapter 4, structure of atom. In last video we have finished Thomson model of an atom and Rutherford model of the atom. In this video we are going to study Bohr's model of the atom. What we are going to study? We are going to study Bohr's model of the atom. Before that, just go through the postulate of Rutherford model of the atom. Clear? So, first postulate was on the basis of alpha particle scattering experiment, Rutherford gave nuclear model of the atom. Rutherford model of the atom can be described as follows. Number 1. An atom consists of positively charged, dense and very small, nucleus containing all the protons, neutrons. Protons have your positive charge, whereas neutrons have no charge. Almost the entire mass of an atom is concentrated in the nucleus. The second one is the nucleus is surrounded by negatively charged electrons. The electrons are revolving around the nucleus in a circular paths at very high speeds. The circular path of the electrons are called orbits. The third one, the electrostatic attraction between the positively charged nucleus and negatively charged electrons hold the atoms together. An atom is electrically neutral. This is because the atom of protons and electron in an atom is equal. The fifth one is most of the atom is empty space. Is this clear? Now, there are some drawbacks also. There are two drawbacks. Number 1, it does not explain the stability of the atom. It does not explain the stability of the atom. Second, according to electromagnetic theory of physics, if a charged particle undergoes accelerated motion, then it must radiate some energy continuously. So these are the drawbacks of Rutherford model. Now, after the gold foil experiment, Rutherford proposed the planetary model of an atom, just like the solar system. The nucleus lies in the center, like this. The nucleus lies in the center of the atom and electron revolves around the nucleus, like your solar system. In solar system, sun is your nucleus. In a solar system, see, sun is your nucleus and all the planets revolve around the sun. That means they are acting like electrons. Similarly, if you are talking about an atom, in atom, a nucleus is a sun and the electrons which are revolving around the nucleus is your planet. Is this clear? So like this, Rutherford has compared structure of atom with the solar system. But the revolution of the electron in a circular orbit is not expected to be stable. Is this clear? It is not expected to be stable. So this research has been done by the Niels Bohr. So first, just go through the you can say the life or the journey of a Niels Bohr, or you can understand who is Niels Bohr. So first, Niels Bohr, a Danish physicist, studied in a Rutherford laboratory since 1912. He was a student of Rutherford. So Niels Bohr, a Danish physicist, studied in a Rutherford laboratory since 1912. He successfully explained the spectrum of hydrogen atom and presented Bohr's atomic model, and he was awarded Nobel Prize in 1922. Who was Niels Bohr? Niels Bohr, a Danish physicist, studied in a Rutherford laboratory since 1912. He successfully explained the spectrum of hydrogen atom and presented Bohr's atomic model. He was awarded Nobel Prize in 1922. Clear? So, basically, Niels Bohr explained the stability of the atom. In order to explain the stability of the atom, overcome the objection against Rutherford model of the atom. What are जो भी drawback थे Rutherford के, उसमें he started work on that. So Niels Bohr gave a new arrangement electron in an atom in 1931. In 1913. Clear? Now, according to Niels Bohr, the electrons could revolve around the nucleus in only certain orbits or certain energy levels. Each orbit, that means they can revolve on a certain orbit, and these orbits are having a different radius. Clear? These orbits are having a different radius. The electrons in each orbit have a characteristic amount of energy, and the electrons which are in orbit close to the nucleus, that means the electrons which are close to the nucleus are having low energy, while those farther from the nucleus. Taking example, this is a nucleus. One or electron is revolving here and one is revolving here. Which one is having more energy? This one, because the nucleus से far है. The electron which are present in a farther orbit are having a more energy, or having a higher energy as compared to those electrons which are close to the nucleus. Clear? The second one is when electron is revolving in a particular orbit or a particular energy level around the nucleus, the electron does not radiate energy. That means they do not lose energy even though it has accelerated motion. Clear? Around the nucleus. Since electron does not lose energy while revolving in certain permitted orbit, they don't fall into the nucleus. See, if they will lose energy, what will happen? They will revolve. At some point, it will lose every energy, all energy, and it will fall down to the nucleus. But Bohr explained that it will, when the electron revolves around the nucleus, it will not lose energy. If they will not lose energy, what will happen? Yes, they are having energy all the time, so it will not fall down. Is this clear? So, we have done this. The electrons could revolve around the nucleus in a certain orbit, and each orbit having a different radius. The second one, when electron is revolving in a particular energy level around the nucleus, the electron does not radiate energy and it has accelerated motion around the nucleus. This point I have explained already. Clear? I think this is very clear to you. Now, Bohr's model of the atom. The first one is, we know that an atom is made up of three particles. An atom is made up of three particles. Number one, electrons. Number two, protons. Number 3, neutrons. Is this clear? An atom is made up of 3 particles: electron, proton and neutrons. The second one, the protons and neutrons are located in a small nucleus at the center of the atom. Clear? The protons and neutrons are located in a small nucleus. In a small nucleus at the center of the atom. Where proton and neutrons are located at the nucleus, and nucleus is present at the center of the atom. The electrons revolve rapidly around the nucleus in a circular path called energy levels or shells. Now, these energy level shells represented in a 2 way. You can represent either 1, 2, 3, or you can represent K, L, M, N, so on, and P. These energy levels are counted from the center to the outwards. See, this is 1, 2, 3, K, L, M, N, O, then P. Is this clear? Now, there is a limit to the number of electrons. There is a limit to the number of electrons which each energy level or shell can hold. Clear? See, K can hold only 2 electrons. That means in first electron you can only locate 2 electrons. L, 8. L, 8. M, 18. N, 32. And N can hold a maximum level, maximum atom. Is this clear? In first cell 2, in second 8, in third 18, and in last 32. And 32 is a maximum number of electrons that we can hold. Each energy level is associated with a fixed amount of energy. The cell nearest to the nucleus having maximum energy. The cell nearest to the electron having nearest to the nucleus having maximum energy, and the cell farthest from the nucleus having maximum energy, which is nearest is having a minimum, and the which one is the farthest is having a maximum energy. There is no change in the energy of electrons. There is no change in the energy of electrons as long as they keep revolving in the same energy level. As long as they keep revolving in the same energy level and the atom remains stable. So the charge and energy level of an electron take place only when it jumps from a lower energy level to the higher energy level. When it comes down from a higher energy level to a lower energy level. Clear? When change of energy will take place? When it will jump lower to higher or it higher to lower. When electron gains energy, it jumps from a lower energy to higher. अगर आपके पास एनर्जी ज़्यादा होगी तो आप क्या करोगे? लोअर से हायर पे जाओगे. एंड जब आपके पास एनर्जी कम होगी तो क्या होगा? आप हायर से लोअर पे आओगे. व्हेन इट विल लूज एनर्जी इट विल कम हायर टू लोअर, एंड व्हेन इट विल गेन एनर्जी इट विल गो लोअर टू हायर. इज दिस क्लियर? So these are the postulate of the Bohr's atomic theory. I am reading once more. Listen carefully. An atom is made up of 3 particles: electrons, protons and neutrons. The protons and neutrons are located in a small nucleus at the center of the atom. The electron revolve rapidly around the nucleus in a fixed circular path called energy levels or shells. There is a limit to the number of electrons which each energy level can hold. Each energy level is associated with a fixed amount of energy. There is no change in the energy of electrons as long as they keep revolving in the same energy level and the atoms remain stable. Clear? After that, the next topic. So our next topic is atomic number and the mass number. Atomic number and the mass number. Let us start with the atomic number. Let us start with the atomic number. We know that protons are present in the nucleus of the atom. So it is a number of protons present in an atom which determines the atomic number. Clear? Basically, atomic number is a number of protons. In a simple language, you can say that atomic number is a number of protons present in an atom. Clear? So with this, we can write the definition of atomic number: the number of protons in one atom of an element. The number of protons in one atom of an element is known as your atomic number of that element. So your atomic number is equal to your number of protons. Is this clear? For example, carbon 6. Here, why its atomic number is 6? Because number of proton present in a carbon is 6. Sodium 11. Why 11? Because number of proton present in sodium atom is 11. Clear? It is represented by capital Z. Atomic number is represented by capital Z. All the atoms have a same number of proton in their nuclei, and hence they have all the same atomic number. If the number of proton which there is, it is a number of proton there which distinguish the atom of one element from the atom of the another element. Basically, your atomic number is equal to number of proton. Clear? The atomic number of element does not change during a chemical reaction. Your atomic number does not change. Clear? During a chemical reaction. The atomic number of an element tell us two things. It tell us number of proton in one of the element, and it tell us the number of electron. Why? Because number of proton is equal to number of electron. Number of proton is equal to number of electron. Now the next topic is mass number. The next topic is mass number. Mass number is represented by A. Mass number is represented by A. An atom consists of protons and neutrons and electrons. Since the mass of electron is negligible, so the real mass of an atom is determined by the protons and neutrons. So with this information, we can write the definition of mass number. The total number of protons and neutrons present in one atom of an element is known as the mass number. Mass number is equal to number of protons plus number of neutrons. Clear? For example, sodium 11 are there, so 11 plus 12. So mass number is 23. So basically your mass number is a mass number of an element is a sum of number of protons and neutrons present in the nucleus of an atom of the element. The mass of the atom is mainly the mass of protons and neutrons in the nucleus of the atom. Clear? Carbon. Mass number is 12. That means 6 protons and 6 neutrons. Aluminium. 27. 13 protons plus 14 neutrons. 27. Mass number of sulfur. 16 protons and 16 neutrons. And whenever you represent a mass number and atomic number to an element, what you will do? Mass number always present at the top. Mass number is present always at the top and your atomic number will present always at the bottom. Mass number will present at the top and your atomic number will present at the bottom. Is this clear? You can write the relationship between the mass number and atomic number. We know that mass number is equal to number of proton plus number of neutron, and we know that number of proton is equal to your atomic mass. So instead of writing here number of instead of writing number of proton, you can write atomic number. Why? Because atomic number is equal to a number of proton. So if atomic number is given to you and number of neutron is given to you, you can easily find mass number. And if mass number is given to you, number of neutron is given to you, you can easily find number of protons, or you can say that atomic number. Is this clear? Now we will do some numerical based on that. They are very simple. Calculate the atomic number of an element whose atomic number has mass number 23. You have to calculate atomic number. Mass number कितना है? 23. And number of neutron is 12. So mass number is equal to, we know that mass number is equal to atomic number plus number of neutron. Mass number is 23. Atomic number you have to find plus 12. When 12 become here to 23 minus 12, it is 11. And 11 is a atomic number of sodium. So this is a sodium. So the element having 11 is sodium. Symbol is Na. So you will write mass number at the top and atomic number at the bottom like this. Is this clear? Now the second one is the number of electron in an atom is 8. The number of proton is also 8. What is the number of an atom? See, it is 8. Atomic number is 8. So that means 8. Second one is, what is the charge of the atom? It is neutral because there is no charge. Why? Because electron is a negative charge and proton is a positive charge. Whole are 8, 8. So it is equal. Number of charges is basically magnitude is equal. So there is no charge on an atom, on given element. Is this clear? The third one is helium. Atom has an atomic mass of 4 and 2 protons in its nucleus. How many neutrons does it have? We know that mass number is equal to number of proton plus number of neutron. Mass number is 4. Here it is 2. The 4 minus 2 is 2. So number of neutron is 2. I think Bohr model of an atom, mass number and atomic mass is very clear to you. In next video, we are going to study arrangement of electron in the atoms, valence electrons or valency electrons, covalency, electrovalency. These are the topics which we are going to cover in next video. Clear? Thank you and Sai Ram.